welcome to Turn Right Machine Works. My name is Keith. Today we have another motorcycle part. This is from the same customer that I did the well repair on that aluminum case where the plug hole that was stripped out. I was just going to blow through this, and this really wasn't going to be a video, but I come across a mishap or something that you got to deal with, and I thought I'd make a video on it. Alright, I'm going to move you over so that you get a good run and view of the project itself. And you can see that I've turned the center in the chuck nice and true, and I'm running this thing between centers. This is an arbor. The arbor was made to run this drum and skim the surface to be 100% true with its mounting flange. And this side of the jig is also to use for the front drum on the bike. So this is a custom tool made to be the tool to spin these parts. And of course I can't just turn this part right now. I have to backtrack, take this off. We're going to find out what's running out on this part. It has all the signatures of an import, but you know, I'll let you be the judge yourself. Okay, I got this in gear. I'm gonna turn it on, and we're gonna watch this run. Now this is rough casting, and this should be running out. There's no problem on there. This is not what I'm looking at. I'm looking at this face and the diameter that we have to turn that the brake pads run against. I expected these to be running out, and that's why we're setting up and running this jig. But right now I'm looking at this flange down here, and it's wobbling. Okay, the diameter here and the diameter here look like they're running perfectly true in the peripheral, and we'll double check that when we get this off of here to get this clearance. Right now I'm going to throw an indicator here and an indicator here. We're going to compare these two surfaces right there. Alright, and of course I have already hooked this up here so that I can come in here, and this is an interpreted indicator. And alright, now I'm not going to put the camera on the indicator so you can see the swing or whatever. I'm going to compare that point, and then I'm going to put this indicator on the mag base here, and I'm going to compare that point. Put this in neutral. Okay, that's on 0 there at that point, and I'm just going to zero this one out here. It really probably should be down in here if we wanted to compare straight in the line with the axis. Okay, but I'm not going to get that technical. Basically, I'm running 7.5 thousandths run out down here at a 4-inch diameter, and up here it has a little bit of a dip between there and there of about 10 thousandths, but other than that I have about a 20 thousandth swing up and down. Okay, now this diameter to this diameter, that ratio is about 2.25. So this 7 out here is respectfully should be somewhere around 15, 16 out here. Alright, so we're getting a little bit more than that. So we expect that this rotor is not running true, but that's how much off. If this is machined off 7 thousandths, you're going to be that much farther out here. So by seeing this, which this side of the face is supposed to register a drum going the other direction, you put the dog on the other thing. This jig is made to go both directions, and when I pull this off of here, you get a better look at it. When I first got the customer came in with the job, I had to chuck this up and polish 1.5 thou off of the register because it was too tight for this to fit. But I wasn't. I was just polishing it. I wasn't really set. I didn't have it set up between centers to actually see if it's running true. So now we're going to go ahead and I'm going to pop this off of here, and we're going to put this in the lathe between the center. This center is perfectly true. I turned it right in here before I mounted this in here. So let me get to pulling this apart and bring you back in and see what we have. Alright, we're ready to put our arbor in, and we're just spreading around. We have plenty on here. This is Extreme Pressure Lube. It's a CEMD product, a concentrated center detent lubrication, anti-scoring. It's special stuff, okay? It's better than boy butter. And I just keep that tube up there, and I think that's probably my second or third tube that I've gone through in my lifetime. But it's the best thing for your centers on your dead centers. Of course, I got a live center over here, but if I was running a dead center, I'd be putting it in here as well. Sometimes if I'm going to be doing a lot of endoing, I just go ahead and fill both centers, and then I just do a quick smear, so it's always here as long as there's no chips getting into it. Slight bit of tension here. All right, tighten up the quill. All right, so I can still run this in the free mode. Now we're going to do some checking. Now I switched the indicators around here a little bit, hopefully that you can see them. Okay, I'm going to set 0 right there. Alright, we're actually getting 8.5. Alright, that's 2.25 times 8.5, which is the total run out right here. So that will give us our ratio. And that is 19 and 19.1 thousandths that it would be causing it to run out on this edge of the drum. This 8.5 thousandths run out here ratios out to be in 20,000. That's pretty close to what we found, with the exception of a 10 thousandths dip in here, which just could be a low rust spot or whatever. This thing is pretty rusty. It's pretty old, but we're going to take a light skim just to create a straight face here and a clean diameter here for the shoes to locate on. Okay, this surface is really nice. We're going to go kiss this on the lapping plate we got over there. We've already kind of polished this up with some Scotch-Brite, and that's when we were fitting this. Nice snug fit. This was a thou and a half high, and I went ahead and I just spun it, holding it on the 3-jaw, and I kind of spun it and polished off the paper. So this run out down here is not going to affect this run out any more than the thou and a half, and that's going to be well in acceptable tolerances, my tolerances that I'm going to allow this for those shoes to sit in there, and we're going to be happy. So we're going to go ahead and face this off right here, and then after we have this running perfectly true, then we're going to bolt the hub back up here, and then we're going to see what the hub's running. Okay, we slipped the dog over and retensioning this. A little bit of friction. You know, it doesn't have to be super tight, and it doesn't have to be super loose. You tighten up the tailstock. You slide this into where it's comfortable. I welded this extension on here a long time ago, so it fits my jaws for the most part. And when this center was new, it was about this long. So over the years here, it's almost time to make another one. And that's just a straight turn shoulder and a little bit larger diameter, and then I just machined the cone on it. Alright, let's put some gear on here. Alright, now you can see that wobbling and walking around. It's, you know, you can't miss 8 thousandths run out. I don't know, you know, evidently this is not a part that goes through QA, or you're looking at the quality of the QA. Alright, so we got this set up in here. Now let's just make the job right, and I'm going to blow this up. Oh, just chalking it up. Here's another tool that we have to fix so that we can use it. Yeah, you have friends like that. You borrow their equipment, and you got to repair it before you can use it. Okay, well, you know, this is the second thing that I'm actually showing you on YouTube, that you buy it and then you got to fix it to use it. So you know, on the Cape here, we have a lot of places. It's called unfinished furniture. I think this machine, these imports should be just considered unfinished machining. Just my thought. All right, we can add some speed in here. Okay, just touching there. We're going to set the 0 here. We know about 5 thousandths. Okay, we're just taking a look at it, and yeah, she got a hollow from here to there. Alright, pretty good finish except for just outside the bolt holes right there. Kind of like when a chip rolls around on your insert there and then scratches the surface behind, it's kind of what it is. Maybe a little bit with some oil. Alright, I like that. Alright, we're going to go ahead and we're going to pull this out and mount the drum back onto it. I'm just going to go ahead and throw this on here real quick so you can see. I'll put it so you can see the needle there. And we're running true. Alright? That even looks a lot truer. You can still see this side running out. But this side here is mine. Now this was running out 4, but we found 5 or 8 on this side here when we got, or excuse me, we were running out about 7, I think it was. But we found 8.5 on here, a little bit greater than over on this side here. All right. Yeah, it's a lot easier when this is loose. Tighten this on here. Okay, we got this back on here in tension. Let's spin it and look at it, see what we got here. This line here and the bore look enormously better. Now let's go ahead and we're going to go ahead and get our indicator against here. We're going to get a readout on here and one on the inside face here. But that really, I believe that this is running as true as we can possibly get it using this jig. I'm saying the face is perfect and the run out is within 1 thou and a quarter, 1 thou and a half. Okay, let's get our indicators on here. Alright, we got our test indicator against the inside surface, which is a little bit rusty, so the needle jumps, but in general we're looking at that movement right there, and it's going anywhere from 5 above to about 3 down below, but most of the rotation it's holding within about 3 thousandths. That little span right there, and then it wants to dip. The same here. Now most of the path around, it has one little low area right in here, and then comes right back up, and then kind of stays right close. Okay. Oh, I'm happy that this is running where it's supposed to be, and I'm going to go ahead and do the skim cuts on it now. So let me change your camera position so you can see a little bit more of the cut. We'll get it cleaned up, and we're going to be done with this job. Okay, we got our boring bar with the CNMG insert in here, and this has got like a 16th. This is the same one that we were boring out some steel rollers that we were making that kind of led up to the face-off competition there, and that Adam and Tom were also playing around with and did videos on. And so I still got this original insert, and I'm still cutting on the same edge. And the main thing is I was trying out these inserts that Adam gave me, and I'm still cruising along with it. And I like this tool because I'm going to be able to bore and face this all with one tool. So I'm not going to need anything more elaborate than I have right in here now. And I'm just going ahead and I like to put a little handy towel down to catch the cast iron. And I'm not going to turn this very fast. In fact, I'm going to slow this down. And I'm going to go ahead and try spinning it there. I want to go ahead and make, I always want, I mean, you could have your project sitting in here and you can have a dog on here and you can accidentally have a gap in here. Alright, and as soon as your tool bit hits here, it goes like this, and sometimes it's enough to grab your bit, and then when it stops or slams here, then it creates a chip on your bit. So always kind of make sure that your back pressure is against your dog when you go to start. Alright, now we're going to go ahead and we're going to touch this off, and we're going to just skip across the face here. I just kind of want to get the feel of this diameter and this setup here and how flimsy or rigid it is. And before we get stuck into a bore here, and I'm just kind of coming over here, and I need to bring my light over here, so. Alright, we're just starting to touch there. And I'm gonna take 5 thousandths. Alright, now I do know that I gotta reverse my feed because I want to come forward. Doesn't need to be 100% perfectly running true out here. This is open to the air, but it is a machine surface in relationship to the bore. And I want to go ahead and put a witness mark, put a machine surface there that we have touched that up. Alright, I don't know if you can see that, but there's a hollow from here to here. It touches right in there, and there's a hollow there, and it touches right there, and touches right there. So it's like touching in 3 spots. We have 3 hollows as well. Very, very faint shadow right in here, almost cleaning up, and this one here is a little bit smaller, and this one here is probably where we had that big 10 thousandths dip and the low there. Alright. Take another 5, and we're going to call that finished. It may clean it. It did leave that little area right between there, and it did clean all the way around here. I'm going to call that 0. Like I said, this is open. This is a non-rubbing surface right here. It's just supposed to be clean, whatever it comes to, a backing plate or a shield on the backside. I'm not sure on the design of this. Alright, now we can come in here and we can hit this diameter here. We may actually have to have a little different speeds or feeds, and we're going to work that combination. We're just going to barely skim. All we want to do is really remove barely amount to make it clean. This is an old part. We don't want to lose any original material that we have to. We just need to get rid of that rust that's on here. Alright, change our feed direction. And I'm going to touch off and see how it sounds. And touching in one spot, 2 spots there. Little graze of the rust there. It is touching there. And grazing the rust right there. Alright. I'm gonna take 5,000s off of here. Let's see what we got. Call that the full depth. I said 0 there so that I can come back to it. Alright. Now when we go for our finish cut there, when we come back out, we'll come away from there so we don't leave a trail on there. Alright, we're going to rotate this around and alright. You can get a look at it there. I'm going to move the camera in position so you can come in and you can actually get a little bit better perspective of what's hitting and what's not hitting. But we are almost 3-sided touching, which is a good sign that we are pretty well close to the original bore. We know that we are registering the bore that we need to match to within the tolerances we chose to go with. Okay, I'm rolling this over by hand from the back side of the lathe so that you can actually see the skipping and how it is making contacts on almost 3 sides. Alright, so we're going to go ahead and we're going to plan what we're going to do for our next cut. We're going to go ahead and take it. It seems that we're not getting any chatter or anything else, but we're not a full cut, and sometimes it doesn't start acting up until you do get a full cut. And then you're going, oh my god. So you gotta recognize that right off the bat. Otherwise you could lose some diameter real quick having a chatter get loose on you, and it's the luck of the draw sometimes. Okay, I'm gonna try another 5,000s here and see how we do. Here we go. Singing a little bit, but I don't think it's going to clean up all the way. So my next pass, I'm going to slow it down. Now the pattern that it leaves in the bottom there, on the surface there, I call that a herringbone, and if you kind of look at it when it's stopped and everything, you'll see it, and it lines up itself, and it does look like a row of ribs in a fish. And herring has a lot of bone, so you know that's where I think it gets its name. Okay, and we're gonna come back out now. Let's go ahead and slow it down and see if we can get a little bit different light on here. Put it in neutral. And I'll go ahead and give it a wipe here for you. Alright, and now you can see the wavy lines that are in there. Give it a couple different light shots here, something like that. Alright, so I call that herringbone. Okay, there's our hollow that we still have left to clean, so we're not 100% clean, so we're still within the minimum cut. Alright, we're going to slow our way down because we want to make sure that we don't get that herringbone. There's a lot of other things you could do. I'm choked up as short as possible right here, and our brake is firm. This part is firm. I think basically we just get down to a decent speed there and we'll create a cut without the harmonics. You can sometimes actually speeding it up past the point of the harmonics, you can get rid of them as well, but sometimes then you end up into a burning chip on different alloys of metals and stuff like that. Now this, we're just going to go ahead and we're going to take 2000s, real light cut. I got to get that. All right, that was great. Customer that I've been talking with down Cape there, he's got a thread issue on a lathe there, and he's trying to adapt a faceplate, run a chuck, and of course on some of these small lathes, you got oddball threads and stuff on the old ones there, and he's got a 1-inch 10 thread or so, and so he's going to try to hunt up a tap there so we can make up a backing plate for him. Alright, so we went ahead and we took a cut around here, and I believe it cleaned up all the way. Yes, it did. It looks good. Now that took a total of 12 thousandths. From the time we were touching the rust surface to finished, it was 12 thousandths. So I feel real good about this job. Now I'm just going to take, and we're going to break this sharp edge right here at the outside corner, and then break it loose from the jig, and this job is done. Alright, this is my regular high-speed bit that I usually just keep in one of my CA2 holders here, and I switch it around. Usually it's facing the other way and I'm doing turning, but when I'm doing a lot of inside or registers for female registers, I go ahead and I turn it this way because it's easy to reach in here where I got room and go ahead and just kiss that chamfer on there. We're set up here, we're going to go the same speed and everything else. And in the same gear as soon as we get into it. Alright, and we're just going to come in and just barely catch that. It is singing a little bit, so we're not going to go any farther than that. We're just going to hold some paper on here until we get a straight edge. Nothing fancy, we're just rubbing that surface right there. Alright, so I mean, that'll be great, and leave it right there. The brake shoes will break in the way they're supposed to, and we're happy that it's running true. Alright, get the vacuum in here so we can grab some of this dust here before we pull that rag. Alright, so this is a wrap on the job, and I just basically brought you in on the video because we're dealing with unfinished tooling again, alright? Or if this was local, then it might be from New Colorado, and that's only fun. You guys, the majority of you in Colorado voted for your situation there, and so I mean you got to expect a little bit of flack. We're not serious. We're just kidding around. I know that you're all going to be holding the same standards that you would as far as how your employees come to work and stuff, and at least I hope you do as well. Our brake drum is complete. Took bare minimum to make this clean and running true, and it was kind of neat seeing the old time thread there, the 3/8 20 thread. It's not a common classification of threading, and it's kind of neat to see that. I mean, shoot, I haven't dug out my 7/16 Allen wrench in a long time, and so that was a little oddball for me today. Other than that, great little quickie job. He can continue on with his bike project. Get her done.